this video we're going to talk about multiplying vectors, which is not something that you have ever seen before. The first thing we're going to talk about is when you take a scalar and multiply it by a vector. So that would be taking a scalar and multiplying it by vector A. Let's just simply that scalar times each of the components. So if we look at the vector A above, which I've got written here, A is equal to 6i minus 5j plus 4k, and I'm going to just multiply it by 3. And that's going to give me 18i minus 15j plus 12k is equal to 3k. Basically what it does is, if I'm multiplying by 3, I'm just tripling each of the components. It would just make vector A 3 times as long, pointing in the same direction. So it just scales it. Now, the scalar product is when you multiply two vectors to get a scalar result. And it's written like this, A dot B. Okay, so it's called a dot product. In math class, sometimes we use dot for multiplication. So we're multiplying these, it's called a dot product. The rules for this are as follows. If I multiply I times I, I'm going to get 1. It's a scalar, it's not a vector anymore. It just has an amount of 1. And if I do j dot j, I get 1. K dot k, I get 1. Whenever I multiply them by one of the other unit vectors, I dot j, that's going to be 0. And the same thing for I dot k, k dot j. You always get 0 for those. What that's going to mean is this. Okay? If I'm doing A dot B, it's going to be AXI plus AYJ plus AZK dot BXI plus BYJ plus BZK. When I multiply this first term by the first term, I get AX times BX, and then I times I, but I times I is just equal 1. Now, if I take that first term, that AXI, and multiply it by the second term of B, BYJ, I have I dot J, which is 0. So I don't have to worry about that term. I'm going to have to worry about the terms where I'm multiplying X times X, and Y times Y, and Z times Z. So it's going to give me this, AY BY plus AZ times BZ. And I would just add those up, and it's a scalar. There's no direction involved. The I's and J's and K's are all gone. Now, another way of finding it is doing this. A dot B is going to equal the magnitude of A, not the magnitude of B, not the cosine of theta. Theta is the angle between A and B. So you can use that if they give you the size of the vector and the angle, rather than giving you the I, J's, and K's. So here's an example. Find the dot product of the two vectors below. Then find the angle between them. So we're going to do C dot D. That's going to be equal to 4i minus 3j minus 2k dot minus 2i plus 4j. And there's no k term for this one. So remember, I only have to multiply the two I terms together. So that's going to be 4 times minus 2. And then I multiply the two y terms together. So it's going to be minus 3 times 4. And then I don't have a k term in the second vector, so I don't have to worry about that. So that's going to give me minus 8 plus minus 12. So that C dot D is going to be minus 20. And it's just a scalar. I don't have to worry about direction at all. Now, there's a second part of this that says find the angle between them. And we're going to use this rule here, okay, in order to do so. So we need to find the magnitudes. So the magnitude of C is going to be the square root of 4 squared plus minus 3 squared plus minus 2 squared. Plug that in our calculator. We're going to find the magnitude of C is equal to 5.39. And then the magnitude of D is going to be the square root of minus 2 squared plus 4 squared. And that's going to give me the magnitude of D is going to be equal to 4.47. So now we're going to say if C dot D equals magnitude of C times the magnitude of D times the cosine of theta. And that's how we're going to find the angle. So C dot D we found just up above is minus 20. Magnitude of C is 5.39. And the magnitude of D is 4.47. And then cosine theta. It's going to be minus 20 equals 24.1 cosine theta. And then if I solve that, I will end up with theta equals 146 degrees is the angle between them. So, after watching this video, you should know how to find the dot products by multiplying the i's and the j's like this. You should also know that you can use this magnitude A, magnitude B cosine theta to get A dot D. And also know that when you multiply a vector by a scalar, you're just making the vector longer or shorter if you're multiplying it by a scalar.